Today we will talk about everyone's favorite area formula. And that is, of course, the Apothem Formula. The Apothem Formula is used to find the area of regular polygons, which are shapes with all of its angles and sides congruent. You may be wondering, what is the big deal? We already have perfectly good square and triangle formulas. Why can't we just use those like civilized people? Well, the problem is, we don't really have a good area formula for heptagons and nonagons and dodecagons and hexadecagons and icosagons. And the Apothem Formula is useful because it's all-inclusive. Well, only for regular polygons, but you can still take a regular polygon with 8,592 sides and still be able to find its area, thanks to the one and only Apothem Formula. So now that you know its vital importance, you might be wondering, what in tarnation is the Apothem Formula? Which is a fair question, and by some crazy coincidence it happens to be what this video is about. The Apothem Formula is written as 1/2 times the apothem times the perimeter, and abbreviated it's 1/2 AP. Now some quick vocab before we start. For the formula, you need to know that the apothem of a regular polygon is the distance between its center and a midpoint of one of its sides. The apothem is the opposite of the radius, which is the distance between the center and one of its vertices. Secondly, the perimeter is just the length of the outer edges, and in a regular polygon it can be found by multiplying the length of a side by the number of sides. Alright. The Apothem Formula uses polygon triangulation, which is just splitting a shape into a bunch of triangles. So for the Apothem Formula proof, we are going to draw a line from the center to each vertex in a regular polygon. Or using some good vocab we learned earlier, we are going to make a polygon where all of the radii are constructed. Now we have a bunch of triangles, and for each side of the polygon there is exactly one triangle. To find the area of the polygon, we have to find the area of the triangles, and we can use the triangle formula, which is 1/2 base times height. The height of the triangles in this scenario is the apothem of the polygon, hence the name the Apothem Formula. The base of the triangles is just the side of the polygon. For each triangle, the area can be found using 1/2 apothem times the side. Now of course we have to multiply the area of each triangle by the number of triangles, which is equal to the number of sides, so our formula is now 1/2 apothem times the side times the number of sides. But wait a minute. Isn't the length of a side times the number of sides just the perimeter? If we substitute in the perimeter, then it should be looking like the formula that we all know and love, which is of course 1/2 apothem times the perimeter. Here we have a simplified version of the process, because simplification makes life so much easier. Now we are going to step it up a notch and apply the Apothem Formula to some common regular polygons. Let us start with the classic square. We are going to split the square into 4 triangles and start substituting some of the variables. The apothem in this situation is equal to 1/2 of one of the sides, and the perimeter is equal to 4 times the side. Our substituted formula is 1/2 times 1/2 times the side times 4 times the side. After simplifying, we get the side squared, which conveniently happens to be the area for a square. Well, squares are one thing. Let's up it up to an equilateral triangle. First off, a less commonly known fact about triangles is that the heights of a triangle partition each other in a ratio of 2:1, so the apothem is 1/3 of the triangle's height. And the perimeter of the triangle is 3 times the side. Substituted, the formula is 1/2 times 1/3 times the height times 3 times the side. The side is the same thing as the base, so our simplified version is 1/2 base times height, which should be looking pretty similar to a triangle area formula that we are already familiar with. In the realm of mathematics, triangles and squares are pretty lame. A real challenge would be applying the Apothem Formula to circles. And I know what you're thinking. A circle has an infinite number of sides, or some mathematicians argue 0 sides, so how are we supposed to calculate its perimeter? Luckily, mathematics is not about one way of solving things, and there happens to be other ways to solve for perimeters. This time we are not going to split the circle into an infinite number of triangles, because that would be a pretty hard diagram to draw. Luckily, we are such intelligent mathematicians that we don't even need an accurate visual diagram, and are going to rely solely on the Apothem Formula. The apothem in this case happens to be equal to the radius, since every point on the circle is equidistant from the center. For the perimeter, we don't even have to multiply the side by the number of sides, and instead we can use another perimeter formula that only applies to circles. That is of course for the circumference, which is pi times the diameter, or pi times 2 times the radius. Our formula is now 1/2 times the radius times pi times 2 times the radius. And if we simplify, we get the circle area formula, which is pi times the radius squared. Crazy stuff right there. Well, I hope you learned a thing or two, and thank you for watching.